begin the design, we started by emphasizing a top-down assembly where everything can be assembled very easily without the need to fit a screwdriver through a small hole to assemble. We laid out all the parts that we needed and started up a CAD model for each part. We then put them together and started thinking about how it would go in real life by moving the parts and thinking about how the surroundings would affect the CAD model. For example, we were initially planning to have a block that would move horizontally to crush the can. But then, after remodeling it and looking at the model, we realized that the crushing block must have an overhang, so after crushing one can, it can be able to move back to the original position before the second can falls in. We also thought about the stakeholders and how they will be using the product to see if it meets their needs. We needed to make it easy to use and for youth to be able to learn about recycling, so we decided to have an open design that will be operated by a park ranger. After this process, it is then repeated multiple times as needed until the whole team agrees that it will not face any design problems after having been completely manufactured.
To present how we created and how our can crusher device works. So to make our can crusher, we started off with a 10-foot long 4x4 piece of lumber. We split it into 4 equal pieces of 2 feet in length to make the legs, as can be seen. And we screwed the legs to the plywood, and we did this for 2 reasons. One, to keep everything in arm's reach, and another reason was to have a trash can beneath, or a collection bin, so that once the cans are crushed, they could be collected in a bin. So we have our crushing block over here, and we need to use this steel plate because the linear actuator can output so much force that it can damage the block, as can be seen. So localized stress are applied to the block, and the block yields and cannot handle these stresses. So a steel plate will prevent these from happening. Okay, let me how it works. So over here at the battery we have a DPDT switch which can reverse the polarity of the voltage sent to the linear actuator, and this helps us because it allows the linear actuator to go both forward and retract. So now I'm going to demonstrate the can being crushed. So I'm going to put here. Now the can is in compression, and I'm going to start the crushing process. The crushed can be seen, and just by visual inspection we can see that the volume has been reduced to more than 20%. Simulation, we decided to test our supports. We first made an assembly that contains the various parts of our supports. We simplified this assembly by removing screw holes from the corner support and removing fillets from the lumber. We also used the split line feature in SolidWorks so that we could apply a load only in the specified area. The following photos show the results of our simulation for von Mises stress. As we can see, our highest von Mises stress was 2.3 MPa, and it occurred at the bend of the corner support. As we can see from this photo, the most deformation will occur at the area which the can is pressing on. The photo shows excessive deformation, which was not observed when testing our prototype. This discrepancy could be due to an error in setting up the boundary conditions or an error in the mechanical properties of wood input.